Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
So students, in the previous lecture we have solved the numerical which was based on the half-life for the first order reaction, as well as we have calculated a numerical in which we have did a sum of rate constant for the first order reaction. And now we are going to do it both simultaneously, means we are going to solve a question in which both the formulas are being required. So let us see how can we solve it. Hello friends. On the screen, as you can see, there is a question which is based on half-life as well as the rate constant for the first order reaction. So let us see the question and extract some few data and fulfill the requirements of the question. It has been asked the half-life of the first order reaction is 1.75 hours, is 1.7 hours. And how long it will take for 20% of the reactant to disappear. So first of all, since the half-life has been mentioned, so from the half-life we could extract the value of K, and this K, that is rate constant, we could use to determine what would be the value of time, which would convert the 100% of the reactant to give 20% of the reactant that has been disappeared. So let us see how can we solve it. We know the half-life formula, that is T half is equals to 0.693 upon K. This is what we know. And the T half which is provided to us is 1.7 hours. So what would be the value of K? We'll substitute this value in the above formula. Therefore 1.7 hour is equals to 0.693 divided by K. Therefore K will be, or means rate constant will be 0.693 divided by 1.7. So let us see what is the value of this. It came 0.407. So now, what will be the unit of this? Exactly. The time mentioned in the question is in hours. So the rate constant unit would be R inverse. So this is the value of K that we have now calculated. But this is not over yet. With the help of this, we have to calculate the time required in which 20% of the reactant has been disappeared. So let us solve that too, which is very much essential. So in the given question, they have been asked that 20% of the reactant is being disappeared. Which means what? It means 100% was the initial reactant. That's true. So therefore, A0 is always 100%. In this case, again, I would say that we are not going to write in gram, or we are not going to write in moles per dm cube in here, because the percentage value is given. And again, it is a concentration term, so therefore we could write in moles per dm cube also. So whenever the question has a percentage value, you have to predict and you have to consider that in moles per dm cube. So after this, 20% of the reactant is been disappeared, means out of 100 moles per dm cube, or the concentration, 20% has been disappeared, means what is left with us? That is, we represent that by 80, and 80 means the concentration of reactant which is been unreacted. So 20% has been reacted out of 100, which means 80% is been left, or I could say 80 moles per dm cube is what concentration of reactant is been left. And we have recently calculated the value of K also. So even we have K with us, which has a value of 0.407 R inverse. So the value has been calculated. And what we have to do is we have to substitute this all values in the equation for rate law for first order reaction or rate constant for the first order reaction, which is K is equals to 2.303 divided by T log of A0 divided by AT. So let us substitute the values. So we would get 0.407, which is equals to 2.303 divided by T. This is the time that we don't know and we have to calculate. Log of 100 divided by 80. So now we are putting the value of this log 10 divided by 8. So we'll get a value of 0.303 divided by T, and we have got a value of 0.0969. So ultimately we have to find the value of T. So now we are going to calculate it. Therefore T is equals to 2.303 into 0.0969 divided by 0.407. And now let us calculate what would be the value of this. So the value of this equation or this numerical will be 0.548. But again, let me tell you what would be the unit of this. This is time, and the half-life was given in R, and based on that we have calculated the rate constant, which was also in R inverse. So therefore this time, which is present now, we have calculated, this will be in R only. So this is how we have calculated the rate constant and the time required to convert a particular reactant to a particular concentration. So thank you friends for watching this video. I hope you have got to know how to solve this kind of numerical, and please share this with your friends and let them know too. Thank you for watching this video, and please subscribe Ekeeda channel. Thank you so much.